Hello everyone, we are here to discuss about solar collectors in Pacific flat plate collectors. Myself Deepak J. 1V20CS037 is my USN from Aryabhatta section. Solar collectors. Collector is a device which absorbs the incoming solar radiation, converts it into heat, and transfers this heat to a fluid, usually air, water, or oil, flowing through the collector. Collectors. Collecting, mounting, fluids are the three divisions, where collecting as flat or non-concentric, concentric or focusing, mounting as stationary, adjustable, fluids as liquid, gas, or air. Flat or non-concentric type collectors. Flat plate collectors developed by Hotel and Wheeler in the 1950s are the most common type of solar collectors, which are widely used for domestic household hot water heating, air heating, etc. Temperature can be up to 90 degree. In the non-concentrating type, the collector area is the same as the observer area. The diagram shows the flat plate type of collector. Flat or non-concentric collector is divided into two types, fluid type and air type. Fluid type. Heat transfer medium is water or any other fluid, liquid. Air type. Heat transfer medium is air or gas. A typical diagram of flat plate solar thermal collector, where it initially as transparent cover, then beneath as observer, as heat transform medium pipe, which contains insulation to it, and framework structure is shown. Components of flat plate collector: glazing, observer, headers, insulation, container. This can absorb both direct and diffuse beam radiations. Glazing, made one made of one or more covers of transparent material like glass or plastic. It is used to reduce convective and radiative heat losses from the observer. It is opaque to the infrared radiations observer. It is usually made of copper or steel metal. The surface is covered with a thin coating of uh, primer, and then flat black paint of eye observer. Huge paint may increase the resistance to the heat transfer. Coating is applied on the surface to maximize the absorbance of solar energy and minimize the radiation emitted by plate. Tubes or headers. A tube that is attached to observer or sometimes it is a part of observer plate. If the working fluid is air, the flow passage to should be below the observer plate to minimize heat losses. Insulation. These are some materials such as fiberglasses, and they are placed at the back and sides of the collectors to reduce heat losses. Example, wool, fiber, etc. Container, which encloses the other components together and protects from the weather. Flat plate collectors design is as follows, which contains header, risers, glazing, observer plate, insulation, black plate as discussed above. Flat plate collectors fluid type. Direct solar radiation falling on the plate as a transparent cover. Anti-reflecting coat is added in order to reduce the damage caused, and diffuse solar radiations falling. Cushion support for the medium is provided as shown, and fluid type beneath the transparent covers, which is followed by insulation. Heat observer plate will be present in between transparent covers and fluid tube. Cross-sectional arrangements through the collector plates. Tube in strip type. In pa in picture A, we observe glazing riser observing plate, where the structure present in insulation is of a hexagonal type, and in B, It is of a medium circle. Cross-sectional arrangements to tube is to observe. Working principle. Sunlight passes through the glazing and strikes the observer plate, which heats up and solar energy is converted into heat energy. This is the heat. The heat is transferred to the fluid passing through pipes attached to the observer plate by means of convective heat transfer. Glazing design. Due to two glass sheets are used, losses due to air convection are further reduced. This is mainly used and important in windy areas. Radiation losses in infrared spectrum are reduced to 25% from 50% due to use of two glass sheets. It is non-economical to use more than two plates, as if the plate increases, it reflects the solar radiation by 15%, the efficiency decreases. The airspace between the cover and observer prevents heat loss by convection. However, if one watches the electromagnetic spectrum, we see wavelength, low frequency. Then, if the wavelength is short, then the frequency will be more. Radio waves have long wavelength and low frequency, whereas gamma rays have high frequency and low wavelength. In between lies the order: radio waves, microwaves, infrared rays, visible light, ultraviolet light, X-rays, and gamma rays. It works on this principle. When the sunlight heat energy falls on the flat plate collectors, there is some coil rolled into it, which may be a water pipe or any coil. Transparent top will be present for the box. Cool water is let into the tube, where the transparent top allows the beam of the light to fall on the tube. The water gets heated up and the water is sent out to the warm outlet. This is solar panel to heat water principle working diagram. Thank you.